Boom! Alright, so we on to rule number 11 in our series on indices. What is rule number 11? Rule number 11 says that the square roots of AB, the square root of AB is equal to the square root of A multiplied by the square root of B. Alright? So root A is equal to, root AB is equal to root A multiplied by root B. So let me do some simple examples, and we're going to use some perfect squares just to illustrate that the maths actually adds up. So let us say, for example, that we want to say the square root of 100. 100 is 25 by 4, right? The square root of 25 by the square root of 4. Now we know that the square root of 100 is 10. So we started knowing the answer that we're going to end up with. But we're going to use a different route. And let me see if we end up with the same answer. So based on this law, rule number 11, we are saying that the square root of 25 by 4 is supposed to be equal to the square root of 25 multiplied by the square root of 4. The square root of 25 is 5 and the square root of 4 is 2. 5 by 2 is, guess how much? 10. Let me try the next one now, just to make sure. Let me see. 144 is 36 by 4. 36 by 4. 36 by 4. We had to get perfect squares all the way through, eh? I just used 4 here, so I'm trying to find another number. 4. The next perfect square after 4 is 16. No. 9. You could use 9. So something by 9. 16 by 9 is 144. Ah, that's it. Right. So the square root of 144, we can express that as the root of 16 by the root of 9. Right? Yeah, sometimes I had to take out, I didn't think up my numbers properly. So the root of AB is root A by root B. That is what the example says. So the root of AB is supposed to be the root of A multiplied by the root of B. Root of 16 is 4. The root of 9 is 3. 4 by 3 is, guess how much? 12. And we know that the root of 144, which is what 16 by 9 is actually 12. Right? So with some simple perfect squares, you could actually see a demonstration of this particular rule. Now this rule is another version of rule 9. Remember, rule 9 had said that rule 9 was simply that AB to the power of n is A to the power of n by B to the power of n. What's the connection between this in black and this in red? The connection is simply that if we let n be equal to a half, then what we have is exactly this. Because I'm a black boy. Okay, right. Because according to this rule, if we let n equal to a half, we will have that according to this rule in red, if we let n equal to a half, we'll have that AB to the power of a half is equal to A to the power of a half by B to the power of a half. And remember, we had said in a previous video that x under a square root sign is the same thing as x to the power of a half, or A, or B, or C, or any number that any term that we care to use. So AB under a square root sign here is the same thing as AB all in brackets to the power of a half. And AB under square root sign being equal to root A by root B is the same thing as AB under square root sign being equal to A to the half by B to the half. So yes, rule 11 is simply a special case of rule 9 where n is equal to a half, and this, we take the time to write this out because that is of special and particular use in a topic called surds, S-U-R-D-S. Right? I will deal with what a surd is in another video, trying as much as possible not to clutter the information too much. All right, as much as we made the point earlier on that we don't always have the luxury of being brief, we try our best not to over clutter. So there's a particular topic, all right, surds, right? We deal with that as a separate matter in another video. All right, so that is rule number 11. Rule number 12 is a variation of rule number 11. So rule number 12, in rule number 11 we multiply, in rule number 12 we divide. So in rule number 12 we are simply saying that A over B all under a square root sign, which is to say the square root of A over B is the same thing as the square root of A over the square root of B. Yeah? And that's it. So again, let me see, boy. Let me use the same numbers that we just used. The same numbers that we just used. We have used the 25 and the 4, and we're going to use the 16 and the 9. Right. So now we need something where we could get, this one a little more tricky, boy. (16 over 4 is 4). 256 over 256 over 16. That's self-explanatory, yeah? We need two perfect squares that could divide into each other. Nine and 3. Alright, let me use simple numbers. I just try to be simple, but sometimes I don't want the numbers to be too simple. Alright? Okay, so let us say the square root of 100 125 over 25. 625. Alright, forget that. Let me use the same numbers we just used. Right? Sometimes I just go overboard and trying to get these numbers to work. Let me say the square root of 256 over 16. Alright? This is the simplest example I could think of for now. The square root of 256 over 16 is the same thing as the square root of 256 over the square root of 16, according to rule number 12. The square root of 256 is 16, and the square root of 16 is 4. 16 divided by 4 is 4. So 256 divided by 16 is how much? 16. 16 squared is 256. So the square root of 256 over 16 will just be the square root of 16, which will give us the same 4. So whenever we work out everything under the square root sign first and then find the square root, which is what we did here, or whether we apply rule number 12 and find the square root separately, you still end up with the same answer. Now we have the luxury of choosing between the two paths if you're only dealing with perfect squares here. If that is not the case, however, then you have a slightly different scenario now that you have to consider. Alright, 254. Yeah man, I have an next example. Think about it. I like to give perfect squares now when we're dealing with square roots to drive the point home, and then we get into the crazy numbers. So if you have 900 over go a little big with the numbers here now. Alright, if you have the square root of yeah boy, life is exciting when you're doing these things, eh? If you have the square root of 900 over 225, aha, thing nice. Numbers looking bigger. The square root of 900 is, and then the square root of 225 is. Alright, so according to this rule number 10, the square root of 900 all over 225 would be the square root of 900 over the square root of 225. The root of 900 we know is 30. The root of 225 is 15. So 30 over 15 is 2. Or we could do as we did a while ago, and we work out the contents of the square root sign. So 900 over 225 is 4. So that is simply equal to the square root of 4. And the square root of 4 will just give you back the same 2 that they had there. See? So with perfect squares, you could see rule number 12 working just as we saw with rule number 11. And this works whether you're dealing with perfect squares or not. But just as we did with rule 11 and 9, I want to establish the connection between rule 12 and rule 10. Because rule 12 is a special instance of rule 10. Alright? So in rule 10, remember we had said that A over B to the power of n was A to the power of n over B to the power of n. Alright? And we are saying that rule number 12 in black over here is a special case of rule number 10 in red over here. And that special case happens when we let n equal a half, just as was the case for rules 9 and 11. If we let n equal a half, then what you have will be that A over B to the power of a half is equal to A to the power of a half over B to the power of a half. And as we mentioned a while ago, if you recall that the root of A is equal to A to the power of a half, and the root of B is equal to B to the power of a half, then, and we know that the root of A over B is A over B to the power of a half, according to this logic here, then yes, you could see clearly that this in black is equal to this in green, which is the same thing as this here, where n is equal to a half. So that's it, right? But the reason why we separate rules 11 and 12 and we actually put them as separate rules is simply because of the extensive use that these things are put to in the topic of surds, as we discussed earlier. You're dealing with surds, so you'll have to deal with situations like this, the square root of a product, right, where you multiply the square root, the respective square roots of each term in the product. The square root of AB is equal to the square root of A multiplied by the square root of B. Same thing over here. You have the square root of a quotient, right, A over B. So the square root of A over B is equal to the square root of A divided by the square root of B. End of discussion. Right? Once you recognize that these are special cases of the respective rules in red, A to the power of n by B to the power of n. Special cases where n is equal to a half, then you don't have a problem. Alright? And that is it for Rule 11 and Rule 12. Alright, so that is more or less it where the indices are concerned. I hope that you would have gone through all of the videos in this series, because everything we mentioned from Rule 1 straight down to Rule 12 is very, very important. And even after you go through the stuff that we mentioned in the videos here, there will still be some little details that you have to get into as you practice. But the only way to do that is to practice. Don't think that just listening to the videos and understanding the videos is sufficient, right? Especially if this is a topic that you may have been having some kind of problems or issues with. Don't take the work necessary for granted. You have to put in the work. You have to put in the time. There is no shortcut. Shortcut is not part of what we do here. Alright? So take care, keep good, and stay in the game. Don't give up.